In this example, we are given the following situation. A ship leaves port on a bearing of 32 degrees. So, a bit of nautical knowledge for you. Whenever you talk about bearing, that means the angle from north that you are headed. So, if the ship left on a bearing of 32 degrees, that means the angle between its leaving and the north line, in other words, the y-axis basically, is going to be 32 degrees. Now, of course, that means if it's 32 degrees here, this must be 58 degrees. How did I get that? 90 minus 32 is 58. And they say that the ship will travel 14.9 miles in this direction. Then, once arriving here, it turns due east and travels 6.2 miles. The question is then, how far is the ship from port, which would be this line here, assuming I could draw a line, and what is its bearing from that port? So, of course, I want to emphasize that this 58 degrees is for that first vector there, not my blue line. So, they're asking, what's this angle? And what's this distance? To answer this, we will use vectors. So first things first, the trip from port, 14.9 miles at a bearing of 32 degrees, well, we just have to decompose this vector into x and y components. Well, how do I do that? I do r cosine of the angle from the x-axis to the vector and r sine of the angle. Well, in this case, my r, my distance, is 14.9 miles times cosine of 58 degrees. Then my y direction is 14.9 sine of 58 degrees. Okay. What about once I get here and travel due east? Well, what is nice about due east is that means there is no north-south direction. I'm going straight in the east direction, or the positive x direction, as we're normally used to thinking in math class. And so this is just going to be 6.2, and then no y component whatsoever. So our answer is going to be involved when I add up the vectors to get over here. So first things first, I'm going to use my handy calculator to determine what 14.9 cosine of 58 degrees is and what 14.9 sine of 58 degrees is. So in doing so, I make sure my calculator is in degree mode, and then I do 14.9 cosine 58, close parentheses, and I get, I'm going to round to 3 decimal places, so this gives me 7.896. Cool beans. And now I do 14.9 sine of 58. Which, once again, rounding to 3 places, gives me 12.636. Okay, now I'm simply going to add these up. So my distance, my d vector, if you like, my vector labeled d, I'll talk about what the distance is and how it's different in a moment. So when I add these up, I just get 7.896 plus 6.2 is equal to 14.096. And the y value, I'm just adding 0 to it, so it doesn't change at all. 12.636. So there's my vector. To get the distance, what I want is the magnitude of the vector. And recall that the formula is that you take each component, the x1, square it, the y1, square it, and if you had more, you'd keep going, and you take the square root of that result. So in this case, it's going to be the square root of 14.096 squared plus 12.636 squared. So I'm going to throw this into my calculator. Square root of, and I'm using parentheses because I'm paranoid, so square root of parentheses 14.096, close parentheses and square, plus parentheses 12.636, close parentheses square, and then on my calculator I need to close parentheses for the square root. If you have the calculator that actually does the square root bar along, then you're fine. I hit enter, And I get that the magnitude of this vector is 18.931, once again rounding 3 places. Note that this does make sense. I traveled 14.9 miles in this direction, 6 in this, so I'd expect this to be a bit longer than that, and it is. Okay, now what's the angle? Well, to find the angle, I'll remember that that is equal to inverse tangent of the y component of whatever vector you have, in this case the d vector, over the x component. So I have tangent inverse of my y component, which is 12.636, over 14.096. So that is exactly what I'll put in my calculator. Tangent inverse of 12.636 divided by 14.096. And that gives me an angle of 41.874 degrees. So there we go. Oh, there we almost go. This is 41.874 degrees. This is the angle from the east line directly up. But would that be my bearing? No, because bearing is always from the north line. So as a final step, my bearing is going to be 90 degrees minus this value, 41.874 degrees. And when I do that, I get 90 minus 41.874, I get 48.126 degrees. And there we go. So, when all is said and done, this ship is 18.931 miles from port, and it's on a bearing of 48.126 degrees. So there we go. As a general rule of thumb, for problems like this where you have a ship leaving port and you have to calculate the total distance after moving around a bunch, you just take all the vectors, break them down, add up all the components, calculate the magnitude of the vector by doing the square root of the sum of the squares, and get your angle by doing tan inverse, and then remembering that, at least in the case of a ship, you always want the angle from the north line rather than from the east line. And that is this example.